Hi, in this video, we have a collection of exam questions that are most commonly tested on resit papers. As I've gone through the solutions, I've included lots of tips on different methods you could be using, how the marks are going to be assigned, that type of thing. So hopefully it's really informative as well, and it's not just a walkthrough of solutions. You can do this in a couple of ways. You can either download the document that's linked so that you've got all the questions, have a go, and then come back to the video to look at the solutions. Or you can just hit pause before I start, and then you can have a go and just press play. All right, let's get on with it. Okay, so this first question is asking us to work out an estimate for the mean height of the teenagers. Now, as soon as I see a table and I read that word mean, I want it to trigger MAD. That is multiply, add, divide, and it basically steps me through the problem. So the first thing I have to do is multiply. Now, what I'm actually multiplying is a number from this group to the frequency. I want to use a number that fairly represents this group, and that would be the midpoint. So I'm going to take the midpoint of all the rows and multiply them through. Once I've done that, I finish the multiply stage and I do my add stage. Obviously, I'm going to add this column. There wouldn't have been a lot of point in creating all that maths. And there is another add that I have to do, and it's the frequency. Now, in this question, they've given it to me already in the question. There are 80 teenagers, so I know that that adds up to 80. I want to add and divide by how many are there. The biggest mistake I see people do is divide by the number of rows. The number of rows are just the table. It's nothing to do with the actual problem. So that is where a lot of people will go wrong. So make sure you add your frequency. And then the last step is to divide to get your solution. Okay, so this next question was actually worth 7 marks in total. So a really nice number of marks attached to the one question. The first part is asking us to expand. Expand means multiply out the brackets. So we've got y times y, which is y squared, and we've got y times 5, which is 5y, and that was for 1 mark. Factorize is doing the opposite. It's putting the brackets back in. So we have to find a times table that goes into both numbers. This one's nice and straightforward. 2 is the highest times table. And it is really important that you get the highest times table. So when those numbers are bigger, do consider that. So what do we multiply 2 by to make 4? That would be 2, and we keep our A with it. And what do we multiply 2 by to make 6? 3. And again, that was for 1 mark. Now, this one was 3 marks. We need to solve, which means we want to find the value of x. At the moment, x is kind of trapped in those brackets. So we're going to expand the brackets in order to release the x, if you like. So that's going to give 10x minus 8 equals 21. And now you use your method for solving equations. I hop, so I'm going to take my minus 8 across. It will land as plus. And then I divide through by the 10, and x is equal to 2.9. The last one is to simplify the expression. So here we're going to be using our indice rules, but there's quite a lot going on. So you want to break this down and do it step by step. So 4 times 5 is 20. And then you've got e to the power of 2 times e. Now remember, there's an invisible 1, and the rule is to add the powers. And then we've got f times f3, invisible 1. So we've got f4. And that was 2 marks for that question. Okay, so we're being asked to work out whether or not Stuart has enough money to buy 4 kilograms of onions. Now, in order to do this, we are going to need to know how much 4 kilograms of onions cost. And we are going to use all that information in the first 2 lines to help us. So onions and carrots together are costing £2.36, but carrots on their own are costing £1.74. So that is actually our starting point for solving the problem. So if 3 kilograms is equal to £1.74, we really want to know what 1 kilogram costs. So we're just going to divide through by 3, and that gives us 0.58. And when we take a look at the first line, it tells us that there's 2 kilograms of carrots as part of that total. So we're going to find 2 kilograms by multiplying through by 2, and we've got £1.16 for our 2 kilograms. So the total of the onions and the carrots together is £2.36. We're going to take off what we now know the carrots to have cost, and that's going to be giving us £1.20 for the onions. The onions are 2.5 kilograms, so I need to divide through by 2.5 in order to work out what 1 kilogram will cost, and that is 0.48. Now I have what 1 kilogram costs. I can take that and times it through by 4, because he's going to be buying 4 kilograms of onions. That comes out at £1.92. Does Stuart have enough money? Yes. And make sure you write that, okay? That way you have demonstrated that you understand all the maths that you've done. Okay, that question was worth 5 marks, which is a good number of marks if you just break that problem down and just do it line by line, step by step. Okay, our next question is a question that people commonly dislike. I think it's probably the best way to put it. People don't like these questions. So I hope I'm going to give you a way of doing this that helps a little bit. Okay, so we've got water flowing through pipes, and we've got 4 pipes taking 12 hours to fill the lake. So just get the sentence that you've been given, all those words, and kind of code it into something a bit more mathematical looking. Now, we're going to be told that there are 6 pipes, and we only want to fill a quarter of the lake, but we'll get to the quarter of the lake in a minute. Let's think about the 6 pipes, okay? If I've got more pipes, it's going to take less hours. So I'm going to work out, using my calculator, by doing 6 divided by 4, what I multiply 4 by to make 6, which is 1.5. So I've got 1.5 times more pipes. So it's going to take 1.5 times less time, if that makes sense. So we do the opposite because we want a smaller number. And then that will give us 8. Now remember, this is to fill the lake. I only want a quarter of the lake. So I'm going to take the hours, which is 8, and divide it through by 4, which will give me 2 hours to fill a quarter of the lake. So if you've got a story, a context that's talking about one thing increasing and the other thing decreasing as a result, then it's always going to be you multiply the increase side and you divide, it's the same number. Okay, so hopefully that technique will help you with these types of questions. Okay, in this question, we're being asked to describe the single transformation. Now, this is really important. If you start mentioning more than one type of transformation, even if you've got the detail correct, by adding more, you won't get any of the marks at all. So the transformation is an enlargement. So we want to get that down first of all. So it's an enlargement. We then want to work out how much bigger. We're mapping ABC, which is our smaller triangle, to the bigger. So we can just look at one of the edges. So if we look at this edge here on the small triangle, the base is just 1 square along, but on the large triangle, it's 1, 2, 3, 4. It's 4 times bigger, so scale factor 4. Now, the next thing we have to write down to get full marks is the center of enlargement. Because these are on top of each other and they share this corner, it means that this corner here is the center of enlargement. So we have got 1, 1 to finish that off. It's 2 marks, so you need to get all of that for those 2 marks. To get 1, you would need to write down 2 of the 3 things. So enlargement, scale factor 4, that would have got you 1 mark. Okay, so this question is another describing transformation. So we've got to find the right transformation. Most people will look at this question and want to rotate it. It has that kind of rotation feel about it. But once you've grabbed your tracing paper and given it a go, you will find that it lands like this. So no amount of rotation is going to make this work. It can't be an enlargement because one isn't bigger or smaller than the other. Another thing that we could try is translation. Translations slide around, and if we slide that over there, it clearly isn't going to work at all. So that leaves reflection. We often reflect in vertical lines. It would look like that. That's not working. Horizontal lines aren't working. So that leaves diagonal lines. And that is what's happening in this particular question. We have a reflection in y equals minus x. So that's what we would write down. Once you've put your diagonal on, you can test it just to check and see if you are comfortable with it. So this corner here goes through an entire square, 1.5, and then it does 1.5 the other side. All right, because the line's diagonal, we go diagonally through the squares as well. So hopefully that has helped with that question. Okay, so our next question is a probability question. We've been given a table with some blanks and we're being told that the probability of taking a green counter is 0.2 more than the probability of taking a pink counter. So the first thing we're going to do is add what we have been given so that we've got that total. And then we're going to take that away from 1 because they should all add up to 1. So I know that green and pink together is going to be 0.8. If I was to just split them in half, it would be 0.4, 0.4. But obviously that's not right because I need a difference of 2, 0.2, I should say. So this is where I'm going to go up by 1 and I'm going to go down by 1. And you can see now I've got a difference of 2. So that is the result. Okay, so for the next part, we're being told that there are 18 blue counters in the bag. So the probability of getting blue is 0.15, and that is from having 18 blue in the bag. Now, there's various different ways of doing this, and it's quite a personal thing, I think. I'm going to do it one way, which might not be a way that you would consider doing. And it's just, like I say, personal because your brain is going to process the way your brain processes. I know that if I want the total number of counters in the bag, I am going to need to get to a probability of 1, and then that will give me them all. At the moment, I've got 0.15 is 18. I'm actually going to work in the 5 times table because it just suits my brain. So I'm going to divide through by 3. That didn't come out very well, which will give me 0.05. So I've gone down. Now, the reason that I've gone down is because I then can see easily all I have to do is multiply by 20 to get it to 1. So when I times that side by 20, I get 120 as my final answer. But as I said before, I think the way that you step through that is a personal thing in the way that you personally see the maths itself. But I just thought I'd model the way I see it. Okay, so the other common probability question that we see are tree diagrams. We've been given some information about a family winning the sports quiz or the music quiz, and they very kindly started the tree diagram for us. So what we need to do is complete it. These branches must always add to 1. So if I've got 0.3 on that, I would need 0.7 on this one. And then I use that fact on all the branches to finish them off. And that's 2 marks. It's lovely, isn't it? Okay, now we've got to work out the probability that they win both, okay? I've only got one route across this map that gives me a win-win situation. So I take the decimals on those 2 branches and I must do something with them to get my final probability. And it is times. We always multiply across. So you pop it in your calculator and you get your answer. And that is 2 marks. So not a bad 4-mark question. Okay, standard form. Standard form is super common. Well, everything is super common. That's why we've got this video, isn't it? But are we using our calculator for standard form? If you have standard form and you have a calculator, you really need to be using it. So for this question, simply put it in your calculator and your calculator will tell you the answer, 1 mark. Now, when you've got to do it the other way, there is an engineering button, ENG, on your calculator that will do the opposite for you. But you do need to be really, really careful. Check that it's programmed correctly because it isn't always foolproof. So I have done this one in my calculator and I have got 7 times 10 to the minus 3. If you don't have that button or you're not sure that you're confident it's working properly, then all you do is move your decimal point and count as you move it, 1, 2, 3, in front of the first number with value. And then you just put that through. Oh dear, I'm not writing this very well. Let's try that again. 7 times 10. We counted 3. It's a small number, so it's minus for the small and 3 for the count. Okay. For the last part of this, we have been asked to work out and then give our answer in standard form, this particular calculation. So again, use your standard form key. Write them as ordinary numbers. Why do that when you can just stick the whole thing into the calculator and get the answer? Because this has method marks and you need to show some method. And that's a really easy way to do it accurately because the calculator's done it. You can then add those together to get your ordinary number. And again, if you know your buttons are working fine, use it to get it back into standard form. If not, what we're going to do is count again. So we go 1, 2, 3. I want 1 digit with value, and then any extra digits will go past the decimal point, times by 10. It's a big number this time, so it's positive with a count of 3. All right, so standard form, really worth getting good at, really worth getting used to that button on the calculator so that you can get the most out of your little machine on the day. 4 marks, really, really nice. Okay, so this next question is a biggie. It was 4 marks, but it was quite near the end of the paper. So we know we're working at that high level on a foundation paper. It's obviously crossover. It's on your higher paper as well. What we need to do is just take all this information. There is a lot happening. So we've got a empty water tank and it holds 2,400 litres of water. We've got 2 companies and we've been given information about those companies that are completely different. Company A is all about how long it takes them to do it in litres, and company B is all about how long it takes them to do it in gallons. Now, if we're going to be able to compare these 2 companies, then we need to be in the same units. So the fact that we've got different units here is an issue that we need to spot. We've been given a conversion rate for our gallon and our litres, so that's going to help us with the fact that these are different. We've got to work out the difference in time that it takes for one company to do it compared to the other. So how do we do this question? We're going to start off with this fact here. Whenever you spot a fact, get it written down because you're guaranteed to need it, and use the boxes in labels because it's a fantastic way of structuring your work. And you're going to see that we're going to use it all the way through this question. It's an incredibly powerful way to set your work up. So I know that 1 gallon is equal to 4.54 litres. So I've got my box holding the numbers and I've got my labeling. And my labeling just helps me make sure that I put things in the right place. So don't be lazy or try and take a shortcut. Put that label in because it will make a difference. Right now, we're not even using it. We're setting it up. So let's look at company A. Okay, so company A. We're being told that it supplies water at a rate of 8 litres in 1 minute, 40 seconds. We've got yet another problem right here. We've got our time given in 2 different units. We need to be in the same units if we're going to be working. And obviously we need to be in minutes because company B is in minutes. So we want to get these the same. How do I write 40 seconds in minutes? Think about what we're actually doing. We've got 40 out of a total of 60 seconds because there are 60 in a minute. When you put that in your calculator, it will tell you that it's 2/3 of a minute. If you look at the decimal, it's just a recurring decimal, and we don't want to do any rounding. So we're not going to use the decimal. We're going to stay with the fraction. So the time for company A is 1 2/3 of a minute. And then I'm going to use my boxes and labels. I know that it can fill 8 litres in 1 2/3 of a minute. We've got a total of 2,400 litres. I've got everything I need to now work out that missing value, that time in minutes. How does the box and label work? If you've never seen this before, you're probably thinking, what is she doing? This number here, I call it the trap number. I can't slide it in that direction because there's a number in the way, and I can't slide it in that direction because there is a number in the way. You always divide by the trapped number. So I'm going to be doing 2,400 divided by 8 times by 1 2/3. That looks like a scary calculation, but remember, you have a calculator that is going to do all of that work for you. So you pop it in your calculator and you get the number 500. This here, when I'm setting up what's going on top of the 8 and what I'm multiplying, it actually doesn't matter which way round I write that. So don't stress over that. I generally use the number that it's in the same column with. So that's kind of like a habit more than anything else. So we now know how long it's going to take company A. We need to look at company B. So here's company B. And we've got their fact, haven't we? That it takes 2.2 gallons per meter. So per minute. So every minute. Our total in the tank is given in litres, 2,400 litres. But I don't have a litres column. I have a gallons column. This is where our gallons to litre fact is going to come in. I want to change 2,400 litres into gallons. So the trap number is 4.54. We're going to be doing 2,400 divided by 4.4. You can show the times 1 if you want or not. Timesing by 1 isn't going to make a massive difference. And that is giving us 528. Squeeze it in. In fact, let me push that up a little bit. 5.63, on and on it goes. Now, try not to round at this stage. It's sitting in the calculator screen anyway, so just leave it sitting in the screen. But what we now have is our gallons to pop in company B, 5.2, 8.6, and on it goes. I can see now that I am going to be doing 528.63, on and on it goes, divided by 2.2. Again, you can show the times one if you want. I can just now hit the divide, pop it in the calculator, and I get the answer 240,288, on and on it goes. I now have my two totals, company A and company B. It says company A would take more time, so I'm feeling confident I've done it right because that is definitely more. And all I need to do now is finish it off by taking it away. So 500 take away 240.288, and on it goes, is 259.71. Always reread that last part. Give your answer in minutes correct to the nearest minute. So 260 is our answer. So it took up quite a bit of space. Hopefully you were able to follow me through with that. That system of setting it into the box and labeling it up for all proportion questions, it works an absolute treat. And if you've been watching my videos, you will see me using it all the time. Okay, our next question is a proportion question. You can see almost straight away without reading it that there's a fact right there. So Blake works 32 hours a week in the UK and is paid £473.28. She's applying for a job, and basically the story is asking us to see if Blake is correct in her thinking about Australia paying a greater rate. So the first thing we really want to do is work out her hourly rate in the UK. So she earns that a week, divide it by the number of hours, and we have got 14.79. So she earns £14.79 per hour in the UK. Now we're going to pop our information, Australian dollars. That's a fact. Facts always go in the top there, okay? Her rate of pay is 26.4. So that's your Australian dollars going in the Australian dollars column. There's our trap number. And you can just divide through, show the times one if you want to. That gives us 14.699, on and on it goes. So round it, and we've got £14.70. So does she get more in Australia? No. And remember to answer that question. And just going back very quickly to this is just supposed to be a helpful structure. If you don't like it, don't want to use it, you don't have to. I'm not here telling you what to do. I'm just hopefully giving you some nice ideas of how to go about answering these questions. Okay, so we've been talking a lot about if there's a fact, use the boxes in labels. And you can see in the second line of this question that there is a fact. So away we go. It takes 30 hours for machines to produce all the plates. But I do need to be very, very careful. I can't just blindly go into this without thinking, okay? It's giving us the fact that they want to make all the plates in 6 hours. But if they want to reduce the amount of time that it takes to make the plates, and they're substantially reducing that, they are going to need a substantial number of machines, and we're going to need more. So this is another one of those questions where the opposite's happening, and we really need to read the context of the story to get that. So for me to get from this 30 to 6, I would need to divide by 5. So I'm going to do the opposite because I want more machines if I'm going to speed up the time. 4 5s are 20, so it's going to take 20 hours. Okay, so we've got quite a lot happening in this ratio question. Again, it's all about breaking it down step by step. If you do that, the chances are high that you will get the first mark. So we've got Chris, Debbie, and Errol. 3.4.2. So I've taken that entire sentence and I've just coded it up in ratio. We're being told that Debbie gets 120. So in Debbie's column, we're going to pop 120. That is enough to tell me what everybody else gets. Ratios are basically times tables. So 4 times something is going to equal 120. 4 times 30 will do that. So I'm going to multiply everything by 30. And that gets me the amount of money that everybody gets. So how much do they actually share? I'm going to add those totals, and they share 270. Now, we know that Chris is going to give some of his away, and Debbie and Errol will get more. But the total that they share isn't going to change. And it's that fact that we take with us into the next step. So we're going to end up with this new ratio of 2.5.3. Now this ratio, as it stands, adds to a total of 10. So when Chris has got 2, Debbie's got 5, Errol's got 3, between them they've got £10. But we know the total they share is 270. Once I make that connection, I can just see, what do I multiply 10 by to get to 270? And then I do the same on this side. That will give me 54, 135, and 81. We are being asked to work out how much Chris gave to Errol. So again, always reread. Make sure that we are answering the question. So Errol now has 81. He originally had 60. So I want the difference between those two. He must have given him £21. Okay, so I can see immediately that this question is a percentage question. I can also see that it's an increase. If I've got an increase or a decrease within the story and a percentage, I know that original times multiplier equals result is going to solve this. I'm going to get straight into doing the multiplier because I know that's my job. So 100%, it's an increase, so I add the 9%, giving me 109%. But I don't want to work in percentages. Divide through by 100, and I know that the multiplier is going to be 1.09. And again, you can use your calculator to do all of that if you want. The story's telling us that the population of a town increased between 2018 and 2019. So the original population was in 2018. It was then increased, and we have the population in 2019. The population we've been given links to 2019. So it's actually the result, not the original. So what I've got is my original, my 2018, that got multiplied by 1.09 to give the new population of 165,680. If I want to know what that original is, I basically want to get it on its own. It's like an equation. So I'm going to divide through by 1.09, and the calculator tells me 152,000. Okay, there's two parts to this question. You just can't see the second part at the moment. So if you have been sort of pausing and pressing play, just be mindful that there will be another one coming up in a moment. So the first part of this is to work out the length of BC. So BC is here. So that's the length that I need to be working out. That's what I don't know. I've been given an angle and an edge and a right angle triangle. All of those clues are telling me that this is going to be a trig SOHCAHTOA question. So I'm going to get my SOHCAHTOA written down ready. So I'm going to label the sides. I always start personally with the given angle. So I've got an acute angle that comes across, and that is my opposite. I then do the hypotenuse, I then do the adjacent, and then I cross off the one I don't need. That has no information on it. I do not need it. That means it's O in A. O in A is here, so my function is tan. I'm going to set up my T for trig. It's the inside of my triangle, and I've got tan 56. O is at the top, which is X, and A is at the bottom, which is 12. This tells me to do X equals tan 56 times 12 into my calculator. Now, the calculator is going to open a bracket. Make sure you close it. If you don't close it, you are not going to get the right answer. And we've got 17.790, on and on it goes. What do they want us to round to? One decimal place. So 17.8 is the final answer. So the second part, again, we've got another right angle, we've got some edges, and we have a missing angle this time. It's still trig. So I'm going to set my SOHCAHTOA up, and then I'm going to do my label. I always go to the acute. In this case, it's not labeled with a number, it's labeled with X, but that doesn't matter. Straight across, that is going to be my opposite. I do the hypotenuse next and the adjacent, and I don't need O. It's A and H, so it's going to be cos. So I'm going to set up my T. I've got cos, the angle is X, 15 at the top, 18 at the bottom. Now keep your cos and X together when you set your equation up to start off with. Now get X on its own. Cos will land as its opposite. And then you just throw that in your calculator and you will get 33.557, on and on it goes. Again, check what your rounding is. It's one decimal place. So our final answer is 33.6. So I hope you have found that useful. I'm planning to do some sort of So I hope that's been a really useful set of questions. I'm planning to do some sort of topic busting videos where we've got a collection of questions that are within the same topic. And then you can really get stuck into something, especially if it's a topic that you need to target. So if you've got a topic that you would like me to cover, please pop it in the comments and then I can add that to the list and hopefully we can get that out as quickly as possible. If you have liked this video, please stick that thumbs up, please subscribe, and please comment, and I'll see you in the next video.